Okay, so welcome everyone to the course Industrial Robotics and Automation. In today's lecture, we'll be studying about the control elements of hydraulic and pneumatic based automation systems. Okay, so even before just starting the control components, if you can just recall from the previous lecture, okay, that I had given on the fluid power systems, I had talked about the generation of this system fluid power, and I had also talked about the transmission and the control. So if you can just look at the picture to your left, okay, you can see a hydraulic systems consisting of all these three components, that is the generation of the power, as well as your transmission of power and the control of the power. Although this is a very simplified system, yet we have all these three elements in the system. Okay, so the components that are actually put under the dotted line is mainly dealt with the generation of the fluid power. Then you have your transmission through your pipes before it actually engages the actuators, that is the cylinders. In between you have your control elements. Okay, so we'll just see what is the purpose of the control elements. Okay, so in this, if you see, the control elements are actually used to divert or to put a fluid, okay, at a particular port, etc., to do your intended function. For example, if you take it here, okay, the control elements actually is responsible for either diverting the fluid to the lower end of the cylinder, which causes the extension of the cylinder, and if the fluid is diverted to the top section of the cylinder, then again the cylinder is retracted back. Okay, so one element is this. Second, if you can just recall, if you just understand the system, okay, the second element can be your elements that actually controls the speed. Okay, so if you recall again from the previous lecture, if you are controlling the volume flow rate that is entering the cylinder, then of course you can control the speed at which your cylinder extends or it retracts. And if you are having a hydraulic or a pneumatic motor, okay, for example a rotor, if you see, so again the rotational speed of the motors can be controlled by your volume flow rate that you are supplying. Second, in the generation part of the circuit, you can see a component known as your pressure regulator. Okay, so what does it do? It actually is a safety device to control your to protect your systems from excessive pressure buildups. Okay, second, if I told you your force is a product of a pressure into area, okay, your cylinder or your piston area, if it is constant, okay, then if you can be able to regulate the pressure, then of course you can vary the forces during your extension and your retraction of the cylinders. Okay, so this was a hydraulic system. If you now see the example or the picture to your left or to your right, sorry, you can see a pneumatic system. Again, if you see in the pneumatic system also, there is a power generation unit in the form of a compressor, which is of course powered by an electric motor in this. And then you have your different air conditioning unit as your filters and your lubricators. To the right you have your actuators, but again before the actuators, okay, you have your valves, control valves. Okay, what does these control valves do? Again, the functionality is same as that of your hydraulic cylinder. Okay, so this actually controls the extension and the retraction of a pneumatic cylinder in this example here. Again, just after the generation unit, if you can see, there is a regulator also even in the pneumatic system. Again, the regulator is for bringing the or for making the system safe against excessive pressure that may build up into the system. And of course, again, as I told you, it may also be able to control the amount of forces, okay, provided your cylinder area, or if you do not change the cylinder piston area. So with the same cylinder, you can do different types of loads by again regulating your pressure. So again, if you go, there are three basic types of control devices. What we have discussed, again, we will be just having a quick recap of it. So the first one is your direction control valves, or DCVs, they are in short known as. So that actually controls your fluid path. Okay, if you see what are the components of the DCVs, of course all the components are not listed here, but again some of the components can be your check valve, your shuttle valve. Okay, we will be discussing in details of all these things. Okay, then you have your dual pressure valves, or it is also known as the two pressure valves. Okay, then of course your two-way, three-way and four-way DCVs. Okay, so these direction control valves, as the name suggests, actually controls the fluid path. Second is your pressure control valve, which protects the system. We'll be discussing this topic in more details when we start the hydraulic circuit design in the next class. Okay, and then finally you have your flow control valves, okay, which actually controls the speed of your actuators by again controlling the volume flow rate of the fluid that is actually entering into your actuators, be it your linear actuators or your rotary actuators. Fine. So with this we will be first seeing the first type of your DCVs, that is your check valve. Okay, it is also known as a one-way or a non-return valve, because as the name suggests, if you can see here, it is actually allowing the fluid to flow in only one direction. Okay, that is in this case from left to right. This is the symbol here. Okay, and if you try to flow the fluid from the opposite side, there would be no fluid flow. Okay, so if this is the symbol, then of course your fluid flow will be only from your left to right direction, and if you try to flow it from right to left, okay, then it would not flow. So what is the construction here? If you see, there is a poppet and you have a spring that actually presses the poppet against this body. So this is what, when your fluid is coming from the left hand side, it pressurizes the poppet and open the port so that you can have a free flow motions from your left to right. And if you try to put the fluid from the opposite side, okay, this side, then what happens, it actually presses the poppet more against your this valve body and it closes this completely. So there is no flow from the reverse side. That is why, what is the use of it? It actually is used to prevent backflow of the circuits. Mostly it is used just after your generation powers. For example, if there is a pump and the fluid, pressurized fluid is flowing through the pump, so you place a check valve there so that the back pressure, okay, or the backflow of the fluid at any instance, okay, if the pressure drops within the pump or for any other reason, you do not have any backflow of the fluid. Okay, so this is a check valve. It is also known as again your one way or your non-return valve, because the fluid cannot flow from the other side. Fine. So I am having a check valve with me. I will be just showing you again. So see, if you can look closely, okay, to the mirror camera. So this is the check valve here. So as you can guess it, this would be my free flow direction. So whenever you have a pressurized fluid, just let me expand a bit more, then it would be, I suppose, clearer. Okay, so if you have a pressurized fluid coming from this side, then this is the poppet. What it would do, it would just go back like this. Okay, it is just moving back. Okay, fine, and it is opening the port here. So that fluid from this, it just pushes and your valves open. Okay, and the other side, if you see, there is a spring, right? If you can see, there is a spring here. So that spring actually keeps this poppet firmly against your valve body. Okay, if you try to put the flow from the opposite side, okay, that is this side, then again you can see that the fluid will actually help the poppet to actually block this valve body, and you will not be able to have any flow in this direction. But if the fluid is flowing from this direction, then again you can see that this has a movement. Okay, if you can see, it moves back. So it moves back and then it opens the port here. Okay, and then you can have your flow from this side. So this is a check valve. Now after check valve, we will be going to your shuttle valve. Okay, so shuttle valve, it is also known as your double check valve. Okay, and it allows fluid to flow through it from one of the two sources. Okay, so again, if you see in this figure, you have two inlet ports, one from the X and one from the Y. Okay, and you have one outlet port in the form of A. Okay, so either you can make the fluid flow from entering from Y and just going out like this in this direction, or if you have a pressurized fluid flowing from this side, then what would happen? This poppet valve will shift this side and block this port, and then you can have a flow through this direction. Okay, the symbol is just like this. If you can say there is a two check valve. Okay, so you have a double check valve arrangement here. So one check valve is this and the other check valve arrangement is this. Okay, so again, if the fluid is coming from this side, then again this path is blocked due to the movement of this poppet here, and then you have your fluid that will just enter from Y and go to the position A. Similarly, if you have your fluid that is entering from the left hand side, that is from the X port, then again this poppet would shift towards the right and block the fluid from going towards your Y port, and then your A port will actually be connected to your X port. Okay, so again, as you see, it allows pressure in a line to be obtained from alternative sources. So if you just see here, okay, in the typical, one of our typical application is seen here. So you have two valves. Okay, so this is a direction control valve and this is another direction control valve. You will be again knowing much in detail as we proceed to the lecture. Just now, just try to focus. So this is a basically a push button or roller type valve. So either you can extend this single acting cylinder through this valve, okay, or you can also extend this single acting cylinder through this valve. Okay, so both the ways you can extend the single acting cylinder. So if you have a pressurized fluid that is coming from this through this valve and it goes towards the X line, then again this will block the Y passage and you will go, the fluid will go through this and your cylinders would extend and again retract back if you just remove this force, because this is a spring return valve. Similarly, if I have to control this cylinder using this valve, that is also possible. So in a typical industry application, say I have a task, okay, in which I want to have a control to that task, okay, say extending the cylinder, and my colleague, okay, he is also doing the task, he can also have a control. So this is just like an OR circuit. So either I can engage a cylinder or he can engage a cylinder. Okay, so if both of us are working on a, suppose a single acting cylinder to get some amount of work done, so it may be possible that either I press the one of the valve to extend the cylinder, or my friend, he also has a one of the control mechanism to actually extend the cylinder. So in this case, shuttle valve is used. It is also known as an OR valve. Fine. Then we come to the next category, and it is next category of the DCVs. Okay, and it is known as your dual pressure valve, or also known as two pressure valve. Okay, and again it performs the function of an AND circuit. Okay, so until and unless the two input ports, okay, the two active input ports are not engaged, you will not be getting any output. Okay, so if you see, it requires two pressurized input to allow an output from itself. So say this is a compressor. It is generally denoted by a triangle here. Okay, we'll be using these notations more often as we go into the circuit. So from here, if you have a pressurized line that goes through this 3x2 valve, okay, and it comes here. Similarly, you have another 3x2 valve here. Okay, this is basically a push button type of valve that is operating, and then you have your valve that is coming to this portion. So until and unless you don't press or you don't engage these two valves simultaneously, okay, till then your this cylinder would not extend. Okay, if you only extend your, if you only actuate this valve, this 3x2 valve, then what would happen? The pressurized fluid would go here through port 1, and what it would do, it would push this shuttle valve towards this side and it will block this port. Okay, so it would block the port for both. It will not allow the liquid to go towards this line, and it will also not allow the liquid or the fluid to flow to this line. Okay, similarly, if you have a pressurized line that is coming from this say input element, okay, and your pressurized line goes this side. Okay, the moment it reaches here, this entire spool will shift to the left and block this port. Okay, you see this square will just come and touch this and it will block this entire line. So you will not be having any outward movement of the fluid either towards the cylinder or to the other input element. So when you have two pressurized lines coming from both the elements, then this would actually keep this spool in the centralized position, and then your fluid from this side, it would just go like this, and from this side also they would take and go like this, and then it would extend the cylinder. Okay, so as it says, one active input slide the shuttle valve and shuts, okay, the airflow towards any direction. If you add two active input devices, only then it allows the liquid or a fluid to flow. So when I'm saying a fluid, I'm saying it is both liquid in case of a hydraulic system and it is air in case of a pneumatic system. Okay, it will only allow the air to flow through the or to the cylinders, okay, or your fluid, only if both of these input elements gives your pressurized line to the either side of this valve. Okay, so this is also known as your in a common language, it is also known as your AND valve. Otherwise it is known as your dual pressure or your two pressure valves. Fine. Now after this we will be going to the other varieties of your direction control valves. It is your two-way valves, and it is also known as your the other type is your three-way valves. Then the third element you have your four-way valves. So if you talk about the two-way valves, okay, so if you see in this picture, it actually allows the motions or allows the fluid to pass through only two ways. Okay, although you are having four ports here, we will discuss in later what does this port means. But the two-way valves actually allows the fluid to flow through again two ports connecting here. If you see, the P is the pressurized port and the B is the port through which it gets connected. Okay. Similarly, in a three-way valve, you have fluid flow in the three directions. Okay, so it may be a case where you have a fluid, these three-way valves may have a one inlet and two outlet configuration, or one outlet and two inlet configurations. Okay, suppose if you have a fluid that goes towards one inlet is there and two outlet configurations is there, then again you can of course divert the fluid towards these two paths. Okay, when you have your one outlet and two inlet, again then the mixing occurs here. Okay, these types of valves are also used in mixing. You can also block one of the port, okay, and allow the fluid to flow from one inlet and one outlet in this by just blocking this outlet. You can also have an out you can just have connect these two ports and block the this port also. Similarly, you can have the other combination also where your right hand side port is blocked and then you connect your port 1 to 2 and 1 and 2 port, okay, and your third port is blocked. So this way you have your three-way valves. In pneumatic circuits or in hydraulic circuits, sometimes it is used to split the connections. Okay, so for example, if you have a circuit going from here, one pressure is just bifurcate into two, and simultaneously it can engage two valves at an instant. Okay, if the valves are operated by a pilot pressure lines. Okay. So, and then you are having a third category as your four-way valves. Okay, if you see the motion, if you just see in this portions, so you can actually have connections from this P denotes your pilot or your pressure lines, and then from the P the line goes to B, and at the same time you have another fluid, okay, line that is connecting your A port to your tank port. These types of valves are generally used to actually extend your double acting cylinders or retract your double acting cylinders. Why? Because in double acting cylinders, if you can recall from your previous lecture, while the double acting cylinders requires one pressurized port to extend, okay, from the other end of the cylinder you also have to have a line that actually drains out the fluid, non-pressurized fluid, back to the tank port. Okay, so if you can see here in this example, if suppose this P element or the pressurized fluid line is connected to your B, and this B port will get connected to one end of your double acting cylinder, which will cause a double acting cylinder to extend, and from the other portion of the double acting cylinder, what would happen? Your fluid will get drained, okay, and where it will go? It will just go from A to your tank port, okay, or your this tank port will be connected to your reservoir, so it will go back to the reservoir. Okay, So these are the uses where your four-way valves are used. Typically in pneumatic and hydraulic systems, it will be used for connecting your double acting cylinders. Okay. So now again, when we talk about direction control valves, okay, we will actually be going more into your like what are the number of ports into the valves, okay, how are they named, how are these valve names, okay, what are the number of positions of the valve, how is the valve actuated, okay. If you can see in the previous pictures, these are only the valves that I showed you, okay. So if you can see here, these are only the valves, okay. These are the spool of the valves. Again, I have some cut sections, I will be showing you those, okay. So these are the spool of the valves, okay, and these are the positions, okay, in which these valves, for example, when these spools are shifts towards the left, then your these positions will get engaged, and if it shifts towards the right, then of course your these positions of the valve will get engaged. So when I talk about positions, I will say here that in one position of the valve, your pressure line, okay, that is your P port, is actually connected to your B port, okay. That may lead to the extending of the cylinder, okay. And say in the next position, when your spool shifts towards the light for the left in this case, then say your this position of the valve is actuated. In that case, your P, that is a pressure port, will actually be connected to your A port, and your drain port, that is a B port, would be connected to your tank port. So that would actually, what would happen, it would cause the retraction of the cylinder, okay. So this is just a symbolic representation, and even in this symbolic representation right now, you don't know what is the actuating mechanism, like what leads the spool to shift to the left or to the right, okay. So that actuating mechanism, it can be a manually actuated, okay. For example, these spools, shifting of these spools inside the valve, that can be manually actuated, that means either through a lever, okay, or it can be say pressed through a push button, okay. Then again there may be some other mechanisms, okay, to actuate. Second, it can be mechanically actuated, mechanically in the sense by using a roller valve, okay. So suppose your cylinder extends and touch one roller valve, and that roller valve mechanism is actually engaging, or it is actually telling your spool to shift either to the left hand side position or your right hand side positions, okay. So that may be another case of how what is your actuating mechanism for your valves. Third, it can also be a pilot pressure, okay. So when I talk about the word pilot, it is actually the pressurized line. So in case of a hydraulic circuit, it would be your fluid pressure, okay, that is your pressurized oil line. And in case of a pneumatic circuit, it would be your pressurized air, okay. So you can also use a pressurized air for your entire generation circuit. For example, if you are using a hydraulic circuit and you have your pump, okay, so the entire pressurized fluid can itself be used to shift the spool either to the right or to the left or to the central positions anywhere, okay. And in case of a pneumatic circuit, you can use pressurized air to shift the spool of the valves, okay. Similarly, and in the fourth position, you can also use a solenoid, I told you. So if you energize the solenoid, okay, it magnetizes, and once it magnetizes, it can actually pull the spool, if the spool is made of a ferromagnetic material, either to the left hand side or to the right hand side, to connect your different pressurized ports to your A ports or your B ports. And similarly, that may result in either your extension of the cylinder or your retraction of the cylinder, or if you are using a rotary actuators, then either it may lead to your clockwise rotation of the cylinder or your anti-clockwise rotations of the cylinder, okay. Your electrical solenoid based circuits will specifically be limited to your electro-pneumatic or your electro-hydraulic circuits. But in the first module that we'll be covering your pneumatic or your hydraulic systems. So in this module, we'll be requiring only the first three, either a manually operated or a mechanically operated or a pilot operated, okay, valves, okay. So the fourth one, that is your solenoid operated valve, that will be seeing its application when we will start the next module, that is your electro-pneumatics or your electro-hydraulic circuit, okay. So how are these direction control valves, okay, what are the symbols of the valves, how is it written, okay, what are the nomenclatures that is used, all these things we'll be seeing here, okay. So see, we generally use a numeric value with a slash, okay, and then followed by another numeric value, okay, and then we write the other portion of the valve, okay. So the first numeric value, okay, while describing a DCV is your number of ports. Okay, so if you see in this figure first, okay, so you see this is one port and this is your another port. So this is a symbolic representation of a valve. Okay, so in actually valves they would not be like this, they will be two ports, but these ports will not be divided into square lines like this. Okay, these square blocks, okay, that is, it is separated, is only for our understanding and for better drawing of your hydraulic or your pneumatic circuits when you actually form a circuit on your own. So in your actual valve it is only the spool that shifts. Okay, so if the spool, say the spool's position is in a certain position in which both these ports are blocked, if you talk about this first one here, so when suppose by any mechanism the spool shifts towards the right or to the left, then again it may happen that both these two ports that are there on the your valve, that gets connected. Okay, so that actuated position is actually being shown here. Okay, so again the first is your number of ports that defined, then you have a slash, and the second numeric value after your slash says your positions of the valve. So okay, in this case if you see this is the ports, what is this? This is a 3x2 control valve. Okay, so how it is 3? If you see this is one port, okay, here this is the 2 port and this is the third port. Okay, and wherever you will be writing those 1, 2 and 3, or if you are using P, A and B, P is a pressurized line, A is another line, T is a port, that part is actually your default value. So suppose that is a default position of the valve. So for example, if you say this valve can have two positions, but what is the default position of the valve? Okay, so I would say wherever I am drawing these two blocks, okay, and the number of ports on both these square boxes will be same. So if the left hand side compartment has 3 ports, again the right hand side compartment will also have a 3 ports. Okay, so only the connection of the ports will differ between the two position of the valves. Okay, so in this position, that is the right hand position, that is the default position, you say port 1 is blocked and port 2 is connected to your port 3. That means this type of valves, if you see, is more suitable for a single acting cylinders. So say suppose I have a single acting cylinder here. Okay, so in this single acting cylinder, if you see, there is one port for extension. Okay, when this is a pressurized port, and when this cylinder retracts, what happens? Your fluid has to drain from this, okay, and has to come back to your tank port. If I say tank, I am actually referring it to your hydraulic circuit, and if I say atmospheric air, I am actually referring to your pneumatic circuit. Say suppose this is a hydraulic cylinder, then when your cylinder is extended and when it has to retract back, okay, when it has to retract back, then what happens? Your fluid will actually drain from this port. Okay, so that for this cylinder to drain, okay, then what would happen? Your two port, if you see in the second example, your port number 2 is actually connected to your port number 3, where 3 is your drain port and 2 is the port that is actually connected to this end of the single acting cylinder. Okay, so that means in its default position, when this valve is not actuated, the cylinder is retracted. Okay, now say suppose in the one position, if I give a compressor source at port 1 to this valve, then what would happen? In its default position, this compressed port is actually blocked. If you see, this is the T, if you can see here, is actually a symbol for your block port. So that means your compressor is not being able to convey any pressurized line through this port, and your cylinder is in its retracted position. Now say suppose if I actuate this valve, okay, this 3x2 valve to this position, and the actuated position is your left hand side position. Okay, so in the actuated position, what would happen? Your port 1 would get connected to your port 2, and port 2 was connected to this end of the pneumatic cylinder. Then what would happen? You will have a pressurized line that will be connected to here, and your cylinder would extend, right? And the moment I again put the valve to its default position, in which my pressurized port is blocked, then what would happen? And my port number 2 is connected to my port number 3, then what would happen? Due to the spring force of this single acting cylinder, the cylinder would retract back and my liquid would drain from this port. Okay. Okay, so these are just the nomenclatures. Okay, so this is a 3x2 valve. Okay, similarly this is also a 3x2 valve, only the configuration is different. This was a normally closed. When I say normally closed, that means your pressure line is actually closed, and in this case it is a normally open line. Okay, so that means if you connect the single acting cylinder to a 3x2 valve that is normally open, then what would be the default position of the cylinder when this valve is not actuated? Then what would be the default position of the cylinder? If you see, in the default position of this valve, port number 1 is actually connected to port number 2. That means you have pressurized line that is coming from here. That means in the default position your cylinder would remain extended, and the moment this valve is actuated, okay, by any means, say manually somebody is actuating the valve, okay, so what would happen? The cylinder would retract back. Okay, so you got the difference, like what is the difference between a normally closed and a normally open valve? Okay, so it all depends upon how your pressurized line is actually connected. Either it is blocked in the default position, or it is connected to the one of the port. Yes.
Sir, can you please explain the 3x2 port normally closed?
Okay, 3x2 normally closed, that means, see, you have actually 3 ports here. 3 ports means 3 openings in a valve. Okay, so before that, just let me show you some valve. Okay, so these are some valves, if you can see. Okay, these are the ports, okay, of the valves. Here you have actually 1 2 3 4 5 number of ports. Okay, and if you can see here, okay, inside this, so this is your spool. Okay, the shifting of the spool says which port can be connected to which port. Okay, it actually opens or closes. For example, if the spool is in one position, maybe this line is actually connected to this line because of the rerouting of the fluid between this. And say if the fluid is shifted to one any other position, then again it may happen that this port is actually connected to this port. But see, the actual your spool shifts. However, to imagine it more accurately, we actually draw these positions into separate blocks. So if you are having a 3 position, you will be drawing 3 blocks. If you can see this here, okay, the picture to your bottom most here. In this valve, okay, how many ports are there? In this valve there are 5 ports. And how many positions are there? There are 3 positions in this valve. Okay, so we write 5/3. Okay, as you had requested to show your normally closed. Okay, so now let us say this is a 3/2 valve. Okay, 3/2, that means there are 3 ports in this valve: 1, 2 and 3.
Sir, please explain the pictorial representation. I can't understand the pictorial representation.
uh, what do you mean? See, the spool shifting inside this are you talking about this
No,
line?
sir. Those are diagrams.
Okay, these diagrams, na?
The nomenclature, sir.
Nomenclatures, na? Yeah, so I'm saying, so see, in this, if you have 3 ports, okay, first what you are going to do, you are going to draw a square. Okay, if your valve has, say, suppose 3 ports, you are first going to make ports, okay, into it. If it is 3, you will be making 3. In case, if in this case, if it is a 5 port, you will be drawing 5 ports: 1 2 3 4 and 5. Okay, whatever ports, if you have to block it, you will just make this symbol like T here. Okay, this shows your block port in this position, and your arrow shows your that your port number 2 is connected to this, and your port number here is connected to these arrow lines. Okay, so and your numbering is actually your numbering that is there only on the default positions. For example, whatever is your default position, in that positions you will number. The left and the right positions would be your engaged position with same number of ports. So if you talk about this 5/3 valves, okay, I would say, what is the default position of this valve? It is the center. It is in the center position.
In the position which are not numbered, so that position will also follow the same pattern as the numbered position.
Yes, of course. Say suppose in the default position, this is a numbered position, and you have connected your pressurized line to, say, port number 1. Okay, that port number 1 is here. Okay, so when this valve is engaged, that means this is port number 1 here, this is 3 and this is 2. In its engaged position also, this will be 1, this will be 3, and this will be 2. Right? So that means in the default position, your pressurized port, say if it is on the port number 1, it is blocked. The moment this valve is engaged, that means your pressurized port will actually be connected to your port number 2, right?
Okay, sir.
Okay, and these are your just your naming, how you write the DCVs, okay, naming. So if I say suppose 5 by 2, what do I mean? My valve actually has 2 positions and it has 5 number of ports, right? If I say 4 by 2, I will say that my valve will have 4 ports, 2 positions. If I say 4 by 3, it means my valve has 4 ports and 3 positions. Okay, why do we require 3 positions? Suppose if I have to control this cylinder, okay, I have to control a double acting cylinder. Why do I require a 3 positions? Anyway, because if I'm having a 2 positions, either the cylinder would extend or the cylinder would retract. What would happen if I have a 3 position valve then?
Sir, the flow will split to 3 different.
Of course, no. You can. What would happen? Generally, your centralized position, okay, that is your mid position. You have all your ports blocked. If you can see in this circuit also. So that means if I have to stop this cylinder somewhere in between, okay. Say if this cylinder is extending, if I have to stop it here. So when it comes in the midway, okay, what I will do? I will just engage my middle position, okay. And then since all the ports are blocked, the cylinder would remain in this position. Okay, so in this way we actually have your direction control valves. Okay, now again I will give you a more detailed look here, okay, of how is it manually actuated, mechanically actuated, okay, pilot pressure as well as your electrical solenoids. Okay, so see the direction control valve that you can see on the left, okay, what is it? It is a manually actuated. Okay, why? Because you have a lever to actuate it. Okay, it is spring centered. How is it spring centered? See, these are the symbols of a spring centered. That means your default positions, since the numbering are in the position on the center, that means 1 2 3 4 5, whatever is the numbering of this valve. If you see, I have only numbered it to the central position of the valve. That means my default position of the valve is the central position. Okay, now if I have to engage it, I may engage it using these positions. Okay, this I may also engage it to the other side also. Okay, but how would the default position be maintained? The default position would only be maintained by your spring that is there on the both sides. Okay, so that means both sides the spring would be there. Now when I just pull the lever, okay, that means my one position would get engaged, and if I push the lever, my other position would be get engaged. So in this, if you count, there are 5 ports and there are 3 positions. So this is a 5 by 3 DCV. But if you give a exact definition of the DCV, then you have to say this is a 5 by 3 manually actuated spring centered direction control valve. Okay, so again I have another element here to just show you, okay, my exact. Say suppose if you can see, okay, this is a valve, okay, and this is the exact valve that I have shown you. That means this is actually manually actuated, spring centered. Okay, it is having 5 ports and 3 positions. Okay, if you count the ports, how many ports are there? 1 2 3, okay, and you have 2 exhaust ports, okay, that the golden color exhaust port. Okay, by looking at the exhaust port, what can you say? This element is for a pneumatic circuit or for a hydraulic circuit? Good, it is for a pneumatic circuit, because I told you that for a pneumatic circuit your atmosphere is the reservoir, you can easily exhaust the gas. Okay, it is an open loop. For your hydraulic circuit, there will be a closed loop system. For example, if I have to have a 5 ports, okay, circuit for my say 5 ports valve, okay, for my hydraulic circuit, then again I can have one valve like this. Although this is also pneumatic, but then these 5 ports can be like this here. Okay, so now you have 1 2 3 blue ports, for example. So this will be your say pilot pressure line port. This is A and B. That means this will actually go to one end of the double acting cylinder, and this one will go to the other end of the double acting cylinders. If you see a double acting cylinder, okay, see I have here also double acting cylinder, right? So double acting cylinders are how many ports here? 2 ports, right? So if I put a pressurized line here, my cylinder would extend, okay, and again during extension also I have to drain through this port, and if I have to retract the cylinder, what I would do, I would put my pressurized line here and my fluid would drain from this side and my cylinder would retract. That means for a double acting cylinder you will be having 2 ports, and these 2 ports have to go to the valve, okay. So say this is the valve, okay, where you have your bottom most position, you have your pressurized ports, and these 2 ports are connected to the 2 ends of the cylinders, okay. Now this is in the central positions. If I engage the lever, if you can see, it is a transparent system, you can see the spool shifting inside. Can you just view it? I'll do it slowly, okay. Just see the spool in the central. Can you see the spool shifting?
Yes, sir.
Okay. So that spool actually connects, if the air is flowing from here, whether it would be diverted to this port, okay, and result in the extension of the cylinder. And if I just put it like this, okay, then again the same pressurized port would now be connected to your another port here in the another position. And in the center position, this spool will actually block all the 5 ports, okay, and my cylinder would retain in its position that is there, okay. So basically what happens, this spool shifts in the valve, okay. So this is the spool that is shifting, if you can see, but of course the entire conduit or the flowing channels through the this spool is very complex in this. So for our simplicity, what we do, if it is a 5 port, we just make a 5 port system there, okay, and then if there are 3 positions, we block those, we actually divide these 5 ports into 3 positions, and we can say which is the actuated position, which is the default position, and which can be a retracted position. Okay, fine. So now after this we have another type of direction control valves, and this is what? Manually actuated spring offset, okay. So see, whenever you are going to have a 3 position valve, in that what you are going to have? Both side spring, because that springs would actually keep it in the center position, okay. But if you have only 2 position valve, then what would happen? One has to be a default position, right? So that default position would get actuated by a spring. So it is known as spring offset, because this valve is actually offset to this position, default position. Whenever you have to engage it, you will be actually pulling the lever to engage it. Till when you are holding the lever, this valve will get engaged. The moment you leave the lever back, what would happen? The spring would again push this valve, that poppet inside the valve, okay, if you can see here, the spring would push the poppet inside the valve and bring it back to its default position, in which again your pilot, say this is a pressurized port or a pilot line, it would be connected to your A, and your B port is connected to your tank port. So this is the default position. However, whenever you want to actuate it, you will be just be putting the lever either in the front or the back position, wherever is the actuation, okay, and then your P will get connected to your B. See, this position shows your actuated position. In actuated position, you do not have any labeling. So that means in actuated position, your P port will get connected to your B port, and your A port will get connected to your tank port or your drain port, okay. And this is the default position. In the default position, your P, that is the pressurized port, is actually connected to your A port, and your B port is connected to your tank port here, okay. And this default position is maintained by your spring offset. So what you will be calling this valve as, it is a 4x2 valve. Why? Because this is 4 ports. If you count 1, 2, 3, 4, how many positions? You have 2 positions. This is the first position, this is the second position, and this is the default position. How I can say this is the default position? Because my either my letters, okay, P, T, A, B, or my numbering 1, 2, 3, 4, 5, in whichever square block I will be numbering it, that would be my default positions, okay. So this is my default position, and this is a 4x2 DCV, which is manually actuated and spring offset, okay. So there are other, even for manually you have another system also, okay. So just let me show you another valve I have here. Okay, so this is a cut section. Okay. So what is this? This is a manually actuated and a push button type. That means I have a push button here. Okay, see if I'm just pushing, can you see this spool movement? I believe you can see. Okay, right? You can see the spool moving inside. That means the earlier valve that I show you, it was a lever mechanism where you was actually engaging the valve using a lever. Here you are actually pushing it. So this is a push button type. That means this is not retentive. Till when I'm applying pressure, the valves are shifting to one side. The moment I leave it, it comes back to the other side. Okay. And then again, it is a spring offset because there is a spring to offset the valve to its default position. When I'm applying pressure, only then it is there. The moment I'm leaving it, it is coming back to its this position. Again, it has 3 number of ports. Since it's a cut section, you can see 1, 2, and here I have my third port. Okay. So 3 port and 2 positions. Right. So this will be a 3/2 DCB, manually actuated and spring offset. Okay, so now let us move to the again another type of DCBs. I told you one was manually, the second one was mechanically actuated. Okay, so you may have a roller valve here. Okay, just like a cam mechanism. Okay, so that means if my cylinder is actually extending, okay, say if this is my cylinder and if it is extending, it actually comes and touches my roller valve here. Okay, so initially this is my roller valve which can actually get actuated like this. Okay, if you see, so this will be fixed in one position. When this will extend, okay, when this cylinder would extend, it would come and touch this valve and close it. Okay, it would just press this like this, right, and it would engage this valve. And the moment this moves backward, again what happened, this is a spring mechanism, this returns to its default position, and again you have your other ports that are engaged, or your default ports that is engaged. So this valve that you can see here, this is generally used to detect what? The end position. This acts like a limit switch. Okay, so when the cylinder is completely extended, it just rolls over this and press this, which actually triggers the signal. Okay, now you can retract back the cylinder. Okay, so these are actually employed, or these are actually deployed towards your detecting the end positions of your linear actuators. Okay, so if I can fit this type of valve to one edge, say this end of the cylinder, and I can have another valve that I can place it to this end. Okay, so whenever my cylinder is retracting back, it is touching this roller valve, and I can have one actuation, say it is telling to extend. The moment it is coming back to this position, again this roller valve is getting actuated and it may tell to retract. So one practical example of a roller valve type of, maybe what, if I want to have a continuous reciprocating motion of a cylinder. For example, the cylinder comes to its retracted position. Once it reaches its retracted position, it extends. The moment it reaches its extended position, again it retracts back. Okay, so one application will be this, by placing 2 mechanically actuated valves, okay, at the 2 positions of these cylinders, I can make it reciprocate, okay, by detecting its end position. Again, so if you see the mechanism is the same, you can again have a different composition. For example, the different configurations. This is a 4/2. Okay, you can also have a 3/2 valve in this. Okay, you can also have a 5/2, right? But the actuating mechanism would be your this roller valve here, or your cam mechanism. Okay, one, and your default position is actually your spring offset. Okay, and among these 2 positions, the upper position is your default or your lower position is your default? Yeah, good. It is a lower position, that is the default position. Why? Because these letters, the pressurized port A, B, and T, they are actually written towards the lower half of those your symbolic representation of your valves. Okay, and in the actuated position, the upper portion is your actuated position, which will actually get actuated once your this roller valve is actuated. Okay, by some mechanism, either something is touching to it or some other mechanism. Okay, so this is a mechanically actuated. Most of the mechanically actuated these valves are used, again as I told you, as a limit switches to detect some positions or to detect sometimes it is also detected to as a counter system mechanism. Okay, so these are your examples of your mechanically actuated spring offset 4x2 DCV. Now the third category comes your air pilot actuated. That means someone would say, why would I have to press the lever? Okay, and somebody would say, why would I have to again ask something to detect? That means if the cam on follow mechanism is there, or if you can see in the previous example a roller valve was there, something to in that your roller was actually touching or was getting engaged to shift the spool. When you also have your pressurized line, okay, that means you can say suppose I want to shift the spool using the same pressure system in which I am working. Say if I am having a pneumatic circuit, I can use it to shift the spool left position or the right position using the compressed air. Okay, the same pressure valve that I'm using. Secondly, if I'm using a hydraulic system, then again the same pressurized oil can be used to shift the spool. Okay, so this is the again a symbolic representation of it, in which your default position is shown here. This is of course of sorry, this would be a 4x3. It is a 4-port. It is not a 5-port system here. Okay, I have just written it wrong here. So this would be your 4 ports, 1, 2, 3, 4. Okay, and 3 positions, 1, 2, and 3 positions. Okay, and this is what pilot actuated. This is the dotted line that is actually showing your pilot actuated valve, and your this is your spring centered. That means the center position is actually energized by both sides spring. Okay, so it is a spring centered air pilot actuated 5x3 DCV. Fine. So I have one DCV with me. Okay, I will just show you. Okay, if you see this here, right? So again, if you just say in the previous configuration that I showed you, this is the pilot port. Okay, now this is the 5x3 DCV. Okay, 5x3. Here again, although in the on the top position I have written 5x3, but this symbolic representation here is wrong. So what are the 5 ports? 1, 2, 3, and the exhaust port, if you can see here. Okay, this and another one here, exhaust port. Okay, so 5. Now what are these 2 ports for? These are my pilot ports. That is the dotted line port here. Okay, let me see, if my pressurized fluid comes here, okay, then that would actually shift the spool towards this side, okay, and engage one of the position. And again, if my pressurized fluid line comes from this side, then again it would shift the spool towards the other side and it would engage my other position. So that means this valve is actually having how many? If it is in a 5x3 configuration, this would have 7 ports. 5 ports for the valve, okay, that is 1, 2, 3, and these 2 exhaust ports. Had this not been a pneumatic valve 5x3, had this been a suppose hydraulic, then again these 2 ports would also be in there for draining out the liquid. And apart from these 5 okay ports, these 2 ports are actually your pilot actuated ports. Okay, pilot ports for the pilot lines. In case of a hydraulic system, this would be connected to your pressurized oil line, okay, for shifting the spool. And in case of a pneumatic system, this is connected to a pressurized gas, okay, that is a compressed gas, so that this gas is actually, this pressurized line is actually helping in shifting the spool. Okay, fine. Now let us come to the 4th category, okay, and that is your operation of solenoid to shift. That means we are actually using a solenoid valve here. Okay, now the exact, if you can see the spool inside the your valve, you can see the spool is very light in nature, the small balls. Okay, so we can have also an electrical circuit which actually energizes, just like an electromagnet, which actually energizes the coil, and that coil would actually just pull the spool towards one side if I engage it, and if I engage the other part of the coil, okay, the solenoid in the other side, then again this would shift the spool towards the right, and that can also help energize my spool, okay, energize my valve by shifting the spool either to the right or the left position, okay. So in this diagram here you can see this is a 4x3 DCV where you have again 4 ports, 3 positions, okay. This is a spring centered, and this is a symbol that on the symbol, if you see, this is a symbol for your solenoid, okay. If you see here, everything has a symbol. This dotted line here shows your pilot, okay, pilot operated. Earlier, prior to this, you had seen this, okay, this circle one. This was actually your mechanically actuated. Prior to that, a lever mechanism here, okay, you are seeing this was actually manually actuated. So these symbols to the engaging side shows you how this valve is actually getting engaged. So this side it is a spring offset, but the engagement of this side is your manually actuated. In this case, this is again mechanically actuated. In this case, it is a pilot line shown by dotted line here, okay. And in case of a solenoid, this is a symbol that shows, okay, this is a solenoid operated valve, okay. So again, if you see, the same spool can be seen here, and these two are the sections, okay, which actually hoses your electromagnets. I also have a solenoid valve also with me that I will again show you here. If you see, this is the valve, okay. Now you can see, since this is a cut section, you can see 3 ports here, 1, 2, 3, and 2 ports at the bottom, okay, so 5. So this is a 5 port, okay, positions 2 5x2 positions, okay, and your this entire black housing to the left and the black housing to the right, okay, this houses your electromagnet for shifting the spools, okay. This is spool. If this side, if you supply again energize it with some electric current, okay, say a 5-volt current or a 24-volt current, anything, then again this would just shift the spool towards this side and engage one part of the valve. And if you energize this part of the valve, then again you can shift the spool to the other side and engage the other part of the valve, okay. So again, this valves will be required only when you are studying the module electro-pneumatic and your electro-hydraulic systems, where all your control elements and those are all electrical powered. But the rest, other 3 categories of the valve, that is your mechanically operated, your manually operated, as well as your pilot pressure lines, they all will be used to designing your pneumatic and your hydraulic systems. Okay. So now the final 2 slides for today's lecture. Okay, so we are going to have just discuss about the different control systems, okay. So see, again, if you see, you will be having some amount of signal input and then a signal processing unit, then you will be having a signal output unit and your command execution, okay. So these 3 units, that is your signal input, signal processing, and signal output, forms your signal control sections. That means how does the signal flow, okay. So once you get the inputs, with the different types of input, you have to process the signal, okay, and then you have to give an output, and that output will again help your execution of the command, and the command execution is a power section. So if you just try to relate this with this figure here, okay, so what are your signal input elements here? If you see, all your direction control valves, okay, in case of a pneumatic circuit, it would be your for example, if I have a manually operated valve and all those things, so these are the signal input. Why is it called input elements? Because you are giving an input signal to, say, extend the valve. That means you are giving some signal, okay, that is fed by the user. So that input is what? You are pressing a mechanically operated valve, okay, or you are manually just pressing a switch. That means these are your input elements. Now what would happen? Say these input has to get processed. If it is just a simple circuit, for example, pressing a valve extends the cylinder, then no signal processing is required. But say suppose I have my 2 valves, okay, and I am making an OR circuit, okay, or an AND circuit, where until and unless I press both the valves, okay, then the output of the both valves will go to a two pressure valve, and then I have to actually actuate a cylinder. So that means if I am using an AND, if I am making an AND circuit, what I am doing, I am actually doing a signal processing through the two pressure valve, right? So if you can see here, all your OR valves, your AND valves, that is the shuttle valves and your two pressure valves, they are known as your signal processing valves. They say what based on the different input elements, how these input elements has to be processed before actuating my output. And what is my output here? My output is my finally my valve. Again, which valve? It will be my valve that is finally going to operate my cylinder, be it your single acting cylinder and your double acting cylinder. So in case of a pneumatic circuit and your hydraulic circuit, these output elements will always be your pilot pressure. Because see, pilot operated valve, because most of the signal elements, when you are pressing the push button, you are actually giving a two pressurized line coming from here. When you are processing a signal, again what would happen, two pressurized line is going through an AND valve, and ultimately output what you are getting, again you are getting a pressurized line, right? Now this pressurized line can be going to use what, either you can directly extend the cylinder, or you can use that to shift the spool of a valve and then again extend the cylinder. Okay, so you will be having your signal output elements and your command executions. See, why it is very important to understand this circuit is that if you understand this part, only then you will be able to differentiate between your pneumatic and your electro-pneumatic portion, or your hydraulic and electro-hydraulic systems. Because in case of an electro-hydraulic systems, what would be there, your signal input element would change. Okay, then your signal processing, instead of having all these things, they would all again get processed through the electrical signals. That is, if you know how to make an AND logic and your OR logic using your different if you connect it in series, then it becomes your AND, and if you connect it in parallel, it becomes your OR. So all your signal processing is actually going through your electrical circuits, and only the execution, that is the power section, for example the extension of the cylinder, is again your pneumatic or your hydraulic. That is why the signal system is known as electro-pneumatic or your electro-hydraulic. That means the power section in both the case, okay, remains the same. That means your single acting cylinder and your double acting cylinder, and your power, that is your fluid power, either be it your compressed air or your pressurized fluid, they both are going to remain same. Your signal control section or your signal processing, these would change. Instead of doing it with your all your these type of valves, they will all be done using an electrical signals. Okay, so if you just see this circuit, okay, if you can just see this circuit here, so see what I am doing, these are my, what are these, if you see now you must be able to easily configure out like what type of valve is this. This is a 3x2 valve. Okay, since there are 3 ports, 3x2 valve, spring offset. Okay, and this is manually operated because a push button symbol is like this. Okay, so this is manually operated. So you have 1 2 3 4 valves. Okay, so these are your signal input. Now what type of circuit you are trying to make, you are saying if I press any of the two switch, that is switch 1s2 or switch 1s3, my cylinder should extend. So what would happen, you will be connecting these two switches to your OR circuit here, this OR valve or your shuttle valve. So this shuttle valve is actually a signal processing. From there what you are going to do, you are going to just shift this 5x2 valve. This is a 5x2 double pilot operated valve. Okay, okay, and this will be either this is the default position and this is the actuated position. Okay, so what would happen with this pilot line, this position would get engaged and your double acting cylinder would extend. Okay, now once a double acting cylinder is extended, the other circuit what you are making is that using an AND valve. Okay, so once it has reached its end position and you press another switch here, okay, so then again you get a signal back here, and that would again shift the valve to its default position and your cylinder will retract. Don't worry too much into this circuit, we will be again designing this circuit again. This are, I'm just showing you what are the input elements here. So all your switches and all these things, your valve, that is 3x2 manually, they are your input elements. Your rural valve also, this is also input elements. The signal processing elements are your, again in this case, your shuttle valve as well as your two-way pressure valve. Your signal output is your double pilot operated valve, and finally your power section, that is the command execution, is your double acting cylinder. Okay, So in the electro-pneumatic circuit, this portion will change, whereas this portion, okay, the pneumatic portion, that is extension, would remain the same. Okay, so with this I end my lecture here for today's session. Thank you very much.